Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create a 3D pixel surface chart with both color-mapped surface and a wireframe on the surface. In this video, I will use the same framework to create a parametric 3D sphere surface chart. Just like so in here, you can see a pretty sphere surface chart with color map and wireframe. Here we will use the Git tool to clone the source code used in the last video. Here is the download link. From this link, you can download the source code used in the last video. Now we start a Visual Studio Code directly from Windows Start menu. Visual Studio Code. This is a Visual Studio Code interface. We can close this page. Now let's start a new terminal window. In this window, we cd into a code folder, cd code. Inside this folder, we create a new folder called GPU45. Make direct md GPU45. Okay, this folder is created successfully. Now we can cd into it 45. We then can clone the source code used in the last video with the command git clone WebGPU44. Then after this command, we have a space and a period. This way we can place all our source code in the current folder. So run this command. Okay, we can check direct. So you can see all the source code already in this folder. Now we can open this folder from Visual Studio Code. Open folder code GPU45. Can close this page. Here contains the source code used in the last video. Now open a new terminal window and run the npm install to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the Node Modules folder. Today we want to create a parametric 3D sphere surface chart. Here is the parametric equations for our sphere. You can see x equal to cosine v, cosine u. U, v are parameters in these parametric equations. Y equal to sine v, z cosine v, sine u. This is our parametric equation for our sphere. Now open the maths.func.ts file from src folder, maths.func.ts file. We need to add this parametric equation for our sphere. Add a sphere function. Okay, here this sphere function contains u and v. We also set a center parameter. This center parameter lets you set the center positions of the sphere. So this x, y, z is parametric equations. So now we can save this file and close it. Next, we need to make some changes to the index.html file. From dist folder, open index.html file. First, we need to change the title from 44 to 45 because this is the 45th video series. So we can also change the H1 title from peak surface chart to sphere surface chart. Here we will use the same parameters as those used in the last example. You can see this is a drop-down menu. Let you select different square image for our wireframe. This drop-down let you select the color map names from 11 predefined color maps. Now we can save this file. Next, we need to make some changes to the main.ts file. From src folder, open main.ts file. Since most code for render pipeline and render path have been already included in the chart.ts file, so here the main.ts file becomes very simple. Here we first introduce create a chart with texture from chart.ts file. Next, from surface data.ts file, here we need to make some changes. The simple surface data. Here we need to change it to parametric because we wanted to create a parametric sphere surface chart. So again, here mathfunc.ts file, we need to introduce sphere instead of peak. Next, we create a new function called create a chart. This function contains several input arguments. Firstly, the texture file lets you select different square image for creating the wireframe. The color map name allows you to specify color maps for our 3D surface. Inside this function, we call the simple surface. Here we need to replace the simple surface data by the parametric surface data. So we need to replace this line of the code by the new code. Replace it by this. So here is the parametric surface data, and here is sphere. This is the value range. For the u is 0 to 2 pi. For the v is minus 2 pi, half pi, and to positive half pi. We then call the create chart with texture to create a sphere surface chart with both color maps and wireframe. The rest of the code is the same as that used in the last example. Here we define the default, the white square image. The default color map we set to the jet. Then we call the create chart function to create a 3D sphere surface chart with default parameters. This part of the code allows the user to recreate a sphere surface chart with different color map and wireframe by selecting them from those two drop-down menus defined in the index.html file. Now we finished the modification to this file. Now we can save this file. Up to now, we have finished all the programming. We can then run the following command to bound our TypeScript code in the production mode. npm run prod. Okay, the bound file is created successfully. Now we can click Go Live link to open Chrome Canary to view our sphere surface chart. Here is our sphere surface chart with default jet color map and a white wireframe. You can see our 3D surface chart looks very nice and pretty. Here we can change the color map by select different color map names. For example, cool, HSV, winter, and so on. We can also change the wireframe color. Here is red, and green, and blue. Of course, the black, but the total disappear. So we change it to red. You can see the wireframe of our chart mapped by red, green, and blue color does not look a pure color. The wireframe depends on the underlying color map. Different locations have different color, you can see. And previously, we have explained the reason for this issue using our CIDR code. Even though we cannot get a wireframe with pure color except for white, we still get a nice looking 3D surface chart here, you can see. Now we have completed this example. In next video, we will create a 3D parametric torus surface chart. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, www.su.net.com. You can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.